Good morning. Welcome, everyone. So, Thursday morning, 9 o'clock, right after the party. You must all really want to be here. My name is Bart Brinkman. I'm a distinguished engineer in the wireless engineering team. I've been at Cisco for about 12 years, 6 of those in wireless engineering. I was in the service provider business, in the CTO business before that. And I was leading the founding team of OpenRoaming before we open sourced it or standardized it in the WBA. So I should be able to answer all your questions about OpenRoaming. I live in Belgium, so pretty much 9 hours away from here, and looking forward to going back tomorrow. All right. No, other one. Questions. There's not too many of us, so we can be interactive, so I'll try to answer all your questions live. If they take a little bit longer, we may kind of wait until after the discussion because we only have an hour, and we have a lot of content to cover. Obviously, you can also ask questions in the WebEx app, and then that'll be available for several more days, and me and some of my colleagues will answer your questions there as well. So let's look at what we'll cover. First, a quick overview of what OpenRoaming is and why we need it. Some of you may already know all of this. What are the use cases for OpenRoaming? And we're going to deep dive into 2 use cases in specific, indoor coverage, and then application-based onboarding for integration into your loyalty apps. We're going to go through the OpenRoaming architecture, and we're actually going to get to configure it too. So we're going to do a demo on Meraki. And then we're going to finish up with the deeper dive and do a packet walkthrough and look at some old-fashioned PCAPs. Yay. All right. What is OpenRoaming and why we need it? Well, let's go back to when we actually kind of founded OpenRoaming. That was right before the pandemic in the 1920 timeframe. And obviously Cisco talks to their customers all the time. Obviously, we have these wonderful sessions here at Cisco Live, but we also do surveys. And then what we saw is that consistently, onboarding to Wi-Fi and cellular to Wi-Fi roaming were in the top 3 pain points. So we thought we have to double click on this and we have to do something about this. Now if you looked very specifically about what kind of problems were behind that, first of all, there is the indoor coverage problem, which is basically typically solved with digital antenna systems, DAS, but they're very expensive, it's complex, and they're slow to deploy. Then the indoor-outdoor experience, right? Roaming from a 5G network onto a Wi-Fi network, you don't have credentials for example, it's not a good experience. Then the other complaints were around kind of the actual onboarding experience onto Wi-Fi, as well as going through captive portals and how that would always be another good experience for guests and be a source of complaints. So that's kind of the problem statement we started with. Now, if we then look at kind of what we were trying to achieve. So to say it in a simple way, what we were trying to achieve is for your device to be always connected to the best available network. And sometimes that's 5G, especially when you're outdoor, right? But indoor, oftentimes that is Wi-Fi. So when there's 3 things that we have to achieve in order to kind of enable this always best connected experience, it's first of all, onboarding onto Wi-Fi has to happen without friction, right? It can't be seamless if there's onboarding friction. We have to make sure that when you walk into that Wi-Fi coverage from 5G coverage, that handover can happen seamlessly, and that we've got seamless interworking so that those 2 paths are always available to the device, so it can make a selection on what path to use best. So the way we thought we could achieve that is by making sure that we had multiple profiles or multiple identities of users already available on the device by the time they walk into a Wi-Fi network. So those could be, your service provider SIM cards, it could be your cable users, it could be your, Google or your Apple user, could be a device identity, could be your enterprise ID, or a loyalty ID from, a store that you shop with or a hotel that you go to. So what we try to do is we try to make sure that access providers can discover identity providers that host those credentials and securely authenticate with them. So what we did is we built an identity federation, and the identity federation consists out of a legal framework as well as a technical standard. The technical standard allows you to discover an identity provider. It allows you to set a policy of kind of who you want to accept in a network. And it also allows you to securely and privately kind of complete that transaction. And we're going to cover this identity federation in this session in detail here. All right, use cases. So why do you want to use OpenRoaming? Well, the first one is kind of obvious. Yeah, you want a seamless guest experience, right? So that's the obvious one. Enhanced indoor coverage, we already talked about that problem statement. So you can use OpenRoaming as a replacement or an augmentation to DAS. And you can also build loyalty experiences with OpenRoaming if you use your loyalty identity, so your retail identity or your hospitality identity, for example. So what we're going to do is we're going to cover the last two in detail. Like the first one is kind of obvious, but we're going to deep dive on the last two use cases. All right, so indoor coverage. So on this picture on the right here, what you see is kind of the cost of various indoor coverage solutions. And the typical one that's deployed is, DAS systems. And as you can see, it's fairly expensive. It's around $2.50 per square foot. If you compare that to a Wi-Fi deployment, it's about a fifth of that, okay? And on top of that, Wi-Fi is typically already deployed in enterprises. So what you get is, you can leverage an existing Wi-Fi network, or sometimes you have to add a little bit of capacity to it. Now, also, if you look at, kind of what buildings are suited for DAS systems, well, it's buildings of around 100,000 square foot or up, okay? And in the US, that's about 130,000 buildings, okay? It's a lot of buildings, but if you look at the smaller buildings, there's actually 5 million of them, right? And those can easily be addressed for indoor coverage with OpenRoaming, with service provider credentials. And if we do this right, obviously, if we address the 5 million buildings, we can also address the 130,000 buildings, right? So we can basically go across the spectrum with Wi-Fi. Now, this is a little bit of a comparison chart, and if we want to go through it in detail, we'll easily spend 20 minutes on it. So I'll let you take this home, and you could potentially use it to talk to other folks in your company. But basically, it compares all of the different indoor coverage solutions, starting from macro outside in, which is do nothing, right, to traditional DAS, to carrier small cells, private 5G with neutral host, a good old-fashioned captive portal, and OpenRoaming. Now, if you look at it from a cost perspective, how easy it is for you to adopt, how much expertise you need to deploy it, what kind of experience your users are going to get, how secure it is, how private it is, and do you own any of the data, right, that comes off the system, or any of the analytics, then OpenRoaming is a pretty good solution. It kind of works across the board. Now, I asked before this session one of our good customers that have deployed OpenRoaming across their venues if we could use some of their statistics, and they graciously accepted. So this is a healthcare customer. This is their usage in May 2025. They accept service provider credentials, so they're US customers, so there's the US service providers. They also accept, cloud and kind of other device identities. This scales. They accepted over 1 million users last month. And the benefits that they see is they have more than 1,000 buildings. So rolling this out for them is extremely fast. So it's they can get indoor coverage in buildings really quickly. It's a low-cost solution because it leverages the network they already have. It drastically reduces coverage complaints, especially in those smaller buildings. They had DAS in some of those larger buildings. They're replacing it. But in areas where they didn't have DAS, they have much less coverage issues. Both the visitors and the staff use it, so they're both very happy with that. And then users mostly do not notice that they're on Wi-Fi. I mean, we have this active here. Some of you are probably using it, right? Either with your carrier credentials or in the Cisco Live app. And a lot of the times, people actually don't notice that they are on. It really lowers the burden on the clinical staff and then ultimately also on the IT staff as well. So that's the indoor coverage solution. The second use case we want to focus on is kind of the application-based auto onboarding. So for that, Spaces has developed an SDK, a software development kit. This is like a small library. It goes in an iOS or an Android app. And it's mated to an IDP that is built into, or an identity provider built into Spaces. So you really don't need any additional infrastructure to become your own kind of identity provider. All you have to do, if you have an existing loyalty app, you put the SDK in it, and then the SDK can help you provision your loyalty credentials against that Spaces SDK. There's also CRM integration optionally here through Firehose API, so you can basically know when someone kind of enters your venue immediately. And then it also supports push notifications. So the push notifications you can trigger, or you can trigger them automatically in Spaces as well. I also have a sample customer here that has implemented this, and I actually have a video. I'll let you listen to them explain why they do it, because listening to me is you don't want to be listening to me for an hour. So let's roll the video and ask them why they implemented OpenRoaming with the Spaces SDK.
Outlet is a global retailer. We have 8,000 stores and 16 brands.
What's very important to me and also to Deleuze, it's really making that difference in our customers' lives to give offers relevant to him or her based on purchases. Is it with inspiration? Is it with deals? It's really understanding them and helping them move forward.
Cisco Spaces was implemented to provide seamless connectivity for the customers. The game changer here is that we know the moment that the customer walks into the store that the customer is there. So we can influence or trigger purchasing behavior. And we can surprise him with a hyper-personalized promotion or a shopping reminder. Cisco Spaces was the obvious choice to deploy because we actually had already Cisco infrastructure available for our Wi-Fi.
The way we are connecting Cisco Spaces today to Salesforce for us is very important because it enables us to make the link to which message the customer is entitled in real time, which offer is relevant for him. I'm convinced that this delivers real value in the sense that we are talking to people there where it matters the most, where the act of purchase is taking place completely in store.
By offering Cisco Spaces together with OpenRoaming, we see more app downloads.
To me, that was satisfying to really put something out there that makes a business impact.
There's so many opportunities to really make a difference and to be relevant in our customer lives. And I think we are just at the beginning, so eager to fast forward and to see where we can land.
All right, so as you could see, they've implemented the SDK into their kind of loyalty, into their shopper app. And this is how you make Wi-Fi connectivity relevant to basically your marketing teams. All right, so where is OpenRoaming? Well, the WBA, who's the organization that kind of standardizes open roaming and runs the root of trust, they have a map. And the map it's not complete. It's basically it's crowdsourced from a kind of war driving app called Weigel, right? And what Weigel will do, it'll look at the Wi-Fi beacons. In the Wi-Fi beacons, there's a roaming consortium identifier for open roaming. If it sees that, it puts a pin on the map for that network. So it's not complete, but it gives you a good idea. I'll share the link for this map in the WebEx Teams room, so you can have a look at where open roaming already is. All right, that was the intro. So now let's do a deeper dive into the architecture. So the basic idea behind open roaming is to not reinvent the wheel, is to leverage what is already there and kind of like take a new approach to it. So there's really two things we need to enable seamless roaming is we need to be able to exchange some policy pre-association. So the device has to know that, hey, there's an open roaming network here. B, my credential is likely to be accepted, okay? The second thing we need is that we need to connect all these access networks into these IDPs, and we need to be able to do that in a scalable and a secure way. All right, for the first thing, what we did is we looked at what was already available, and there's a protocol that has been around since 2010, 2011 called 802.11u. It's part of the Passpoint specification, and it basically allows you to do, have a query and a response, and you can get kind of a list of domains, RCOIs, realms, and so forth that are supported in this network. Okay, so we use that. And we repurposed some of the attributes there. So not much change was required here. Now, on kind of connecting access provider and any providers, there we had a bigger problem because the solutions that were out there were bilateral agreements. So which basically means a VPN and lawyers, right? Because there's contracts involved. And then there's roaming hubs as well. Those things scale to, maybe hundreds of participants, but not really, millions. And obviously, everybody has to make money here, so, you cannot deliver kind of a free solution on top of that. So what we did is we actually built and standardized an identity federation to replace those bilateral agreements and roaming hubs, but we made sure that the existing business models could still work under that identity federation. So let's drill down a little bit in the building blocks of that identity federation, and we're going to identify kind of 5 key building blocks. The first one is the federation itself. It's a PKI-based trust model and a legal framework, and it's managed by the Wireless Broadband Alliance, which basically makes it open. Any vendor or any network can join. The federation dynamically discovers its peers. So that basically means that as an access provider, you can discover who the identity provider is for a specific user. And that happens through DNS, and we're going to walk through that in detail. There's dynamic policy. So the roaming agreement happens with every authentication, and it's governed by that policy. So access networks will determine a policy of who they want to accept. Identity providers will determine a policy of which access providers they want to roam with, okay? A lot of the identity providers, they're open to roam with anyone, right? But there's some that, are a little more closed. And then security, so, access networks and IDPs, they authenticate each other, right? Because they want to know who they are. And then they set up a TLS tunnel, and all of the communication that they do happens over that TLS tunnel. And then, last but not least, we allow for proxy services or value-added services to be deployed on the federation as well. Why would you do that? Sometimes it's settlement, right? Sometimes there's paid relationships, and then sometimes it's identity providers that don't do EAP, right? Because this is all EAP over RADSEC. and then there's a proxy in between. All right, let's have a deeper dive on the federation architecture. So we talked about there being a legal framework and a PKI framework. So this is the basis of it all. This is how access providers and identity providers trust each other. So the legal framework consists out of 3 agreements. One agreement the access network signs, which basically will govern how they behave, what service they have to offer. There's an identity provider agreement that they sign, which will basically govern how they behave on the federation. And then there's an end user terms and conditions. The end user terms and condition is like a Wi-Fi acceptable use policy, so it's kind of what you're used to serving to guest users. The end user terms and conditions are within the responsibility of the identity provider. So they have to make sure that their users sign this before they actually get a credential that works on OpenRoaming. So what you'll see if you'll sign up to a credential for OpenRoaming, you'll see that there'll most likely be an end user agreement that will be displayed. If not, it's part of the agreement that you made with the provider when you kind of signed up to their credential. All right, so this legal framework is enforced by a PKI framework. So the WBA is the root of trust. Under the root of trust, there's a policy CA. The policy CA has a policy OID in it. That policy OID has a version that maps to the version of the legal agreement. So you will always know, this user, this access network, this identity provider, they signed this document, all right? And under that, there are signing ICAs. So these are the actual CAs that can sign certificates and bring new access providers and identity providers into the federation. So Cisco is a signing CA, Google's a signing CA, the WBA themselves are signing CA, and then Kirio is also a signing CA. Now, what does that mean from a Cisco perspective? Well, if you turn on OpenRoaming in Cisco Spaces, you will automatically get, you will have to sign the access network agreement. It's a click-through, and then you will automatically get a certificate signed for your organization. You will not see that this happened. You don't really have to do anything. The certificate will get automatically signed and renewed, but it's there. All right, now let's look at how this is implemented in Cisco. So as I just said, OpenRoaming is a Cisco Spaces service, right? And so you can deploy OpenRoaming on a Catalyst network or on a Meraki network. On a Catalyst network, so you'll have your access points, you have your controller, and then there's another element that you need to deploy, the Cisco Spaces connector. You do that for all kinds of Spaces use cases, but for OpenRoaming specifically, there's a hotspot container that goes onto the Spaces connector. Now, what does this hotspot container do? It does this PKI management, so it makes sure that you have a certificate, right? So it talks actually to the CA. It does the DNS-based IDP discovery, so when it gets an anonymized username, like an access request, it'll go figure out who the IDP is. It does all that TLS tunnel management to the IDPs. It proxies radius to RADSEC. And then in case that the controller doesn't have all the attributes that the federation requires, it'll add attributes. An example of that is location attributes, for example, that get pulled from the location hierarchy of Cisco Spaces. All right, so that's the Catalyst architecture. The Meraki architecture is kind of similar, but there's no on-prem element like a hotspot connector. So in this case, Cisco Spaces actually performs that function. The Meraki AP will set up a RADSEC connection directly to Cisco Spaces. And it's not radius, it's RADSEC here. And then it will, so Spaces will do all this work that connector does, all the PKI management, the IDP discovery, and so forth, okay? This is available as of 31.1.6 and for 6 and 7, and then 30.8 for Wi-Fi 5. Some of you working with Meraki probably say, hey, that's like really new. or really the latest software version. OpenRoaming is available since 28.5 with a slightly different architecture. In the older versions, the radius traffic goes over next tunnel from the AP into the Meraki cloud, and then it gets proxied RADSEC from the Meraki dashboard to Spaces. But now we're going direct. Yeah.
So now with the latest version, it is implementing this version of the RADSEC.
Yeah, RADSEC direct from the AP. So the reason we did this is it's more scalable. You know, obviously there's no need to go through dashboard.
Are there any Cisco space license required?
Yes, absolutely. Yeah. So you need so OpenRoaming is in the kind of essential tier, and then SP offload is in the advanced tier. So if you buy a Wi-Fi 7 AP now, it would come with it.
We need by the advanced license.
Yes, correct. Yeah. Yeah. Well, you can do essentials OpenRoaming, but if you want offload or the loyalty app, then you need advanced. Yeah. 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 All right. Okay, so let's now, so we know how it works on Meraki and Catalyst. Let's try to configure it now. So there are 4 easy steps to configuring OpenRoaming. 1, create an OpenRoaming profile in Spaces. What does this do? Well, it lets you configure your policy. So who do you want to accept, right? And it lets you specify an SSID. 2, get that hotspot connector set up. 3, pick a controller you want to deploy it on. And then 4, configure the SSID on the controller. On the Meraki side, same thing. Create an OpenRoaming profile. There's no connector, but we need to link the 2 platforms, so we need to enable Meraki API. Select the Meraki network, configure the SSID. So it's really easy. We're going to demo it today on Meraki, because it is the fastest and what can fit in this session. So let's go. So the first thing we're going to do is prerequisites. We're basically going to go to our AP and check that we have like a minimum version. So we're going to make sure that we are running the right MR version, and this is a 29. So it'll support OpenRoaming, but with the old methodology. Then we're going to go to settings, and we're going to actually check that Meraki API is enabled. So this should pretty much all be done already. You see there, it's enabled. And then we're actually going to go create an API key for Cisco Spaces to use. So we're going to generate the API key, copy and paste it. You know, don't try to use this one. I already deleted it, so you're not going to be able to connect to my network. And so that's the first step. And then we're going to go configure that Meraki API key on Spaces. So we're going to add it here. And then now this may take a little bit of time as Spaces connects to Meraki and kind of pulls back all the organizations and the networks that are associated with you. But eventually you'll get a green light here. Then you're going to configure the scanning API as well. The scanning API you don't really need for OpenRoaming, but it allows you to get location data so that you actually know where your location or where your OpenRoaming users are. So you'll copy the URL from Spaces there, add the validator from a Meraki perspective, and then after you've added that validator, you will pick a scanning API version. You want to pick the latest version. That's the most scalable one. We'll go back to Spaces, copy the secret into the Meraki dashboard here, and then save. And then this will enable the scanning API. So now we have OpenRoaming and, we have the API key and the scanning API configured. Now we're going to kind of import our networks from Meraki. So we pick an org, and then we pick a network or all of the networks in the org to import. So now we're importing the location hierarchy. We're importing all the APs. So now we know which APs belong to this tenant. This is important. You know, if we want to show statistics, you know, we do that based on the APs that are in the tenant. Okay, this was all prerequisites. We haven't even configured OpenRoaming yet. We still have to get started. So we're going to do that right now, actually. So we will now go to the OpenRoaming app in Spaces. And we're going to click Setup. And then here we're going to create our OpenRoaming profile. So the OpenRoaming profile does a few things. It sets up your access policy, so that's who you want to accept. It creates your SSID, right? And then optionally, it configures carrier offload. So that's why if you want to do like DAS replacement, indoor coverage, you have to configure carrier. You have to accept the carriers. The access policy, first there's like some access groups that you can configure, and we'll talk about those in detail. We'll accept everybody here. And then there's preferred credentials that allow you to prefer certain credentials over others. Then we configure our SSID here. And then we'll look at advanced. The SSID will be enabled, and then we'll enable fast transition here as well. So we get smooth AP to AP roaming. Carrier offload, optional. So if you turn that on, you can pick the carriers that you want to accept on your network here. We're not going to do that today. And then in the end, you get a summary of your access policy you've configured. And now you can take the next step. Now here, in Catalyst, we'd configure a hotspot connector. In Meraki, we just have to make sure that our API is connected. I'll finish and then we'll configure the actual Meraki network. So we'll click Configure Meraki Network for OpenRoaming here. We'll pick an organization. We'll pick a network in that organization. And then we'll pick the profile we just configured. Right? It shows us the profile again, so we know what we're configuring. And then when we click Next, it will actually configure the Meraki network through Meraki API. Now, this takes a little bit of time, usually like maybe 10 to 30 seconds. You can see the status here, so it's still pending. But if we go back now to the Meraki network, we can go check the changelog, and we can go see if those API requests were properly executed, and there's 2 of them. So if you go changelog, we should see, those are the 2 API requests that we see there. So now, there's 2 things we can go check. It's our hotspot configuration, right? It's the 802.11u configuration there. And it's the SSID. So we can see the hotspot configuration. We see the OpenRoaming roaming consortium OIs there. And then the SSID is already enabled as well. Now, if we go check our AP, and if we have any OpenRoaming enabled devices here, you can see that they're already attached. So this is about 5 minutes worth of work to kind of try this out on Meraki. And you had a question, so yeah.
Can you name the SSID something other than
Yeah, you can name it whatever you want. So because we're doing the SSID selection based on 802.11u ANQP, the SSID name doesn't matter. All right, so you name it whatever you want. All right, so yeah. Yes.
But you also have to sign an agreement with the individual carriers.
It depends. Some carrier like there's in Spaces there's an app to sign up to AT&T. So the UI won't let you activate AT&T until you activate the app. Okay. And then T-Mobile for now is still they don't care. So you can just sign up to T-Mobile.
How long does if you do that? How long does it take for them to accept the agreement?
It's really quick. It's within a day. Yeah.
Okay.
Yeah.
Will you get any revenue sharing back from them?
No, it's an everybody wins. Yeah, I mean, obviously you can go talk to AT&T if you have a really large venue. They may, want to give you some money, but by default it's an everybody wins. Yeah, I think you were first.
So is the authentication based off of the SIM card on the device?
Yeah, for service provider it's EAP-SIM, but it supports any EAP methodology. So there's some IDPs that use TLS or TTLS as well.
So the user doesn't have to install
No.
certificate on the phone or anything?
No.
So it's piggybacking off of the SIM card already?
Correct. It's automatic. Yeah. I think there was a question there first, and we'll come back to you then. Verizon, we currently have in trial at one customer, so they will be available in the near future. Yeah.
One more question. So Android and iPhone, is it built in natively now, or do you still have to go get the app?
It's built in natively in Samsung and Google Pixel, right? Not yet in Apple.
So for the iPhones, you have to go get an app.
You have to go get an app, get a profile, or use your service provider. Yeah. Yeah.
I was going to say, we're a hospital here in San Diego, and we use OpenRoaming, and we have T-Mobile and AT&T working, and you can also use either your Apple ID or your Google ID to log in, and it works great for like the doctors, because then every couple of days when they come back, it just auto connects instead of them like
So I don't hear you very well, but
I was just saying it works great.
Awesome.
For the doctors, because they don't have to like log in on the Guest network.
Yeah.
And then it just auto remembers them even if it's been like a week. It just logs them back.
Yeah. Awesome.
What app are you using? I think we set it up in
We also have it deployed in one of our communities, and we don't have an app required. We don't require people to download an app. It just connects automatically.
With service provider credentials. Yeah.
So is that the difference? I mean, you didn't check the carrier offload.
I didn't hear, yeah.
So does that mean you have to download the app?
No. I mean, like I have a Samsung device. It's built in there too. So, so depends on what device you have. So Samsung ID supports it too.
What does the carrier offload do that OpenRoaming?
It enables service provider as an identity provider. There, you have to do an extra step to do that. Yeah.
Okay.
So if you don't enable that, then your SIM credentials are not enabled. If you enable it, your SIM credentials are enabled. Okay? All right. Okay. The deep dive, packet walkthrough. So we'll take this step by step. And we start with discovering the SSID. So what happens here is the device will see a beacon, right? And then it gets the opportunity to do an ANQP request. So basically to kind of figure out, do I have a credential that's going to be accepted here? So in the beacon, what we'll see is that there'll be an interworking tag. That interworking tag will have an access network type. Why is this important? This is free public network. It will tell the device, what type of Wi-Fi network this is. And there's a little trick that you could use here. Free public will tell it, okay, it's a free Wi-Fi network, so I can start doing my background tasks, right? I can start downloading updates and so forth. If you configure this to be a chargeable network, it won't do that, right? So you can kind of influence the behavior of the devices here a little bit. So in this case, it's free public. And we also say here that we support the access network query protocol. So now the device says, I can do ANQP. And we also say here we support OpenRoaming. This is the WBA RCUI. This is a Cisco legacy API RCUI. We developed OpenRoaming and then standardized it. So we had our own RCUIs before we brought it into the WBA. There's a list of RCUIs here. This kind of tells devices which types of categories of users that might be supported. Mostly people just use the top one and says, hey, OpenRoaming's here, then just ask me more, right? The next step is ANQP. So now the device said, okay, this is an OpenRoaming network. I saw it in the beacon. I'm going to kind of see what's supported here. So what it'll do, it'll send an ANQP request. So this is basically, here's my question I have to you of who is supported here. So domain names, these are what you configured in the policy as preferred domains. So consider these as like the home domains. Like if a device has a bunch of profiles configured, these will always have priority. So you could say, if you have your own app and you also do service provider offload, for example, and you want people that have your app to always use that credential, you'll configure a preferred domain, and it'll show up in the domain list here. Okay, roaming consortium list, so these are the RCOIs we just saw. 3GPP cellular network information are your carriers, okay? And then NIRELMs are, it's kind of the same as domain name lists, or they're FQDNs, but they don't have priority. They're kind of roaming domains. They're actually the last in the priority list. So the priority list is exactly actually how it shows up here. And then finally, you've got your operator-friendly name here. That's what's going to show up on your screen. Okay, so in Apple, it shows up under your SSID, and on an Android device, it actually shows up instead of your SSID. Okay. Now then, we've got the response here. So in this case, what we see, we got a NIRELM list, and we have a bunch of service provider realms here. So your service provider realms show up there, right, in your 3GPP info. So this is your 3GPP cellular network information. But service providers often also put in their realm so that they're absolutely sure that when a network is configured with either, that it works. The format of those realms are always WLAN.mobile network code. That's a code that mobile country code.3gppnetwork.org. So those mobile network codes and mobile country codes are identifiers that the GSMA gives the service provider, so they're unique to that service provider. And then we've got a preferred domain here too, so we just explained that. So those domains will always be selected first. And the friendly name here is OpenRoaming, but that could be your preferred friendly name in your profile. All right, so now the device actually knows whether or not it has a profile that kind of maps to this policy. So now it can decide either I don't have a profile, I do nothing, or I do have a profile, I'll try to authenticate. So that's the next step. So it'll issue an ePOL start and try to authenticate, and then present an anonymous identity and with that anonymous identity, we'll try to discover who the IDP is. And this works as follows. So we get ePOL start, we get an EAP identity request, an EAP identity response with an anonymous @domain.com. That radius access request goes to the connector, so this is a Catalyst network. And the connector will do an NAPTR query with that realm. And you can simulate that on your laptop right now. You can kind of look at discovering an OpenRoaming network. In this case, this is sdk.openroaming.net. And what we get back there, if we do a dig to the Snapter record, we get AAA plus auth, radius, TLS, TCP. So this basically means this endpoint supports authentication, right, over radius, over TLS, over TCP. So that's RADSEC, right? And we get a service record. Now, the next thing the connector does is resolve that service record. So dig -tsrv, and then what we get back is a port number, 2083, and an FQDN. And obviously, we resolve that FQDN as well to get an address, right? So basically, this allows you to discover what an endpoint does, what protocol it uses, what port it uses, and kind of where the endpoint is. So we have everything we need to know now to connect to that IDP. Now, there is an exception, and it's again the service providers. So GSMA controls the 3gpp.network.org top-level domain, and they use this for roaming between service providers, right? So service provider to service provider roaming, and that happens on a private network called the GRX. So they use these MNC 410, MCC 310.3gppnetwork.org domains for roaming on this private network. So they have specified, hey, service provider, if you advertise on a public network, you have to add a .pub identifier to your DNS record. So if you do a dig -t napter wlan.mnc410.mcc 3GPPnetwork.org, which is the AT&T realm, you're going to get nothing. Okay, but if you insert pub in it, you're actually going to get AT&T's NAPTR record. Now, the connector does that automatically. You don't have to worry about it. But just for troubleshooting, right, you'll be like, oh, AT&T doesn't work. I'm going to do a dig, for that network. And then you're just going to see like, oh, they're not advertising anymore. But yeah, you have to use pub, right? So that's a gotcha. All right, so now we know how to connect to the IDP. So we're going to set up a tunnel. This is pretty straightforward. It's a standard 4-way TLS handshake. There's just a few things that happen additionally. The connector will verify not only your certificate validity and so forth, it'll also look at your CN and see that it maps to your FQDN for your radius server so that you're not impersonating someone else. And also that you're authoritative for the realm. So it'll map the realm in your username to a subject alt name in the certificate. And then the IDP, it may just do your certificate validation, but there's also something called an operator ID in your certificate, which identifies you as an access network. So if they have a kind of a policy that only allows certain access networks, they'll be checking that as well. All right, so once that is done, the TLS tunnel gets set up, and we can start using it. Now, if you have any problems in TLS tunnel setup, the way I troubleshoot this is with OpenSSL as client, and then you can connect to the IDP on port 2083. And then typically what happens, there's some issue in the certificate chain, so you want to check that the certificate chain is actually properly published. If you want to see the actual certificate, you can use show certs. If you want to see all the messages for further debugging, you use -MSG. Yeah?
Sorry, this is probably a really awkward question, but is OpenRoaming a service that you can overlay on an existing SSID, or do you have to have a dedicated SSID just for?
No. The only requirement is that there's a secure SSID. So it will not work on an open SSID, but you can run it on an already existing secure SSID. Yeah, not an awkward question at all. All right, so we've done IDP discovery. We've set up our tunnel. Now what we're going to do is authenticate across that tunnel. So we can now actually use a radius over TLS. And as we just talked about, you can use EAP-SIM, you can use EAP-TLS, EAP-TTLS, or any other EAP method. Like the hotspot 2 or the passpoint spec support says, it's SIM, aka TLS or TTLS. But in OpenRoaming, you could pretty much run any EAP method. But we're going to look at TTLS here, but we're going to look at kind of the areas that are kind of similar or common to EAP methods. So we already talked about what happens when you start the session. It starts with a GAS request, which is your ANQP query or ANQP response. You associate. After the EAP identity request, we get an EAP identity response. And the first access request has an anonymous username in it. We do the IDP discovery, the TLS tunnel setup, and we have our first message, our first RASEC message go across. And then, so let's take a look at that access request. So what's important here is that your username is anonymized, right, because of privacy. You'll see your NAS identifiers that either pertain to your AP or your WLC. And it's important that the call station ID has your AP MAC address and your SSID in here, because that's used for statistics in spaces. So if your call station ID is not properly configured, you won't see any statistics in spaces. Now spaces will automatically do this. It's not something that you have to do by hand, but still, if you're looking at why am I not seeing any statistic in spaces, this is most likely the reason. Now we'll look at, so once the access request gets to the IDP, it'll issue a challenge. What's important in the challenge is that the IDP will request a specific EAP type. In this case, it's TTLS. And then we will run TTLS, so we'll set up a TLS tunnel and exchange a username, password, or another credential inside that TLS tunnel. And then at the end, what we will do is we'll issue an access accept. Now there's two attributes that are really important here. Attribute number one is your username, and attribute number two is your chargeable user identity. So what's in those attributes? You've got two identifiers here. The username identifies a device, right? So it identifies your device. And then the chargeable user ID identifies you as a user. So what you see here is that the user ID, or the username is an identifier generated by the IDP, and your chargeable user ID is actually my email address, right? However, you will only see an email address if a user explicitly accepts to share email addresses with access providers, because by default, OpenRoaming will be private, and this will be a hashed identifier. Now, the sharing of those user IDs typically only happens in this kind of loyalty experience where the network is also the IDP. You know, in other scenarios, mostly there's anonymous identifiers here. All right, so we'll finish off with a little bit more explanation on privacy. So we just saw that, we're authenticating, or we're kind of selecting that domain based on an anonymous identifier, and then we're setting up a TLS session. And then, so all of the authentication is private. The access network actually never sees who is authenticating, other than which realm they are or which identity provider they have. So any identity information that is returned by the IDP. So the IDP is responsible for the user's privacy. And they'll return those two identifiers, but typically those two identifiers will be anonymized, so it'll be like a hide my email scenario, right? So the device ID will be anonymized, the user ID will be anonymized, and then only when the user consents, an identity will be shared. So that's how kind of OpenRoaming kind of maintains privacy by default. All right, so we're through the packet walkthrough, and we have a few minutes left. So conclusion, well, it's really not hard to try this. So you can, if you don't have a Spaces license, you can get one for free. You can get a trial license for free. And Spaces licenses these days come with every Wi-Fi 7 AP that you buy. So normally, if you buy a new AP from us, it'll come with a license. You can get a Meraki trial as well. Once you have that Spaces account, go here and try to activate OpenRoaming. If you want to learn more, I included a few references here. Going from the Catalyst config guide, the Meraki config guide, the overall Spaces config guide. If you want to learn more about the connector, the SDK, so the DevNet link there for the SDK is there, and or the WBA and OpenRoaming in the standards in general. You can find some links here. Obviously, I also want you to evaluate the session. It's important for us to understand what we need to improve, and you can actually win something as well. And then finally, I'm here still for at least another half hour for questions. So, come talk to me if you have any questions. You can ask questions in the WebEx Teams room as well, or you can, after the Teams room closes, you can send me an email. I'm always available to help you answer any questions that you have. So thank you very much. I hope you enjoyed the session, and have fun in the rest of Cisco Live.